Hello, my friends. Welcome to Origins. My name's Donn Chapman. It's such a privilege to have you with us today. I'm your host, and you know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. And today we have a great guest with us. I've really come to become very fond of this man, both as a scientist and as a friend. Dr. Danny Faulkner is here with us. Good to have you with us, Danny.
Thank you. It's good to be here.
How wonderful to have you with us. Today we're going to talk about design in astronomy. So connect those two dots for me.
Okay, really, you know, there are two explanations of how we came to be, the world around us and us both. Either it happened through evolution, which I define very broadly as a purely physical, purely natural process. And some biologists might object and say, well, that's not what biological evolution is. But you see, evolution is not just in biology and geology, it's also in astronomy, cosmically, society, history, law, everything people do has been affected by evolutionary thinking.
Right.
And so I want to broadly define creation to be a supernatural process. Now that's pretty broad. I want to make very sure everybody understands what I'm talking about. I'm not talking about some pantheistic sort of thing or even some other God. I'm talking about the God of the Bible,
right.
Yahweh. But I want to define those very broadly. You have, again, a purely natural process or a supernatural process. And the two are really incompatible. There's no need for evolution if you believe in creation. That changes your worldview. You may ask, well, why is it important? Really what it does is it affects the way we look at the world.
Oh, it really does.
An evolutionist looks out and he sees chance, and he sees gradual processes, he sees struggle, he sees chaos, just probabilistic things happening. But a creationist looks out at the world and he sees design, he sees purpose in things. And so as a working hypothesis, we might expect in any aspect of the world around us, things would either appear designed or they will appear non-designed. And so that's what we all talk about, this design implication we find in any science, including astronomy.
If there's a God and I see His purpose and His design in things, then the implication is there's purpose and design for me.
Yeah.
My life now has structure, meaning, and purpose. If everything out there is by chance and I'm just an accident, then there's no purpose to my life.
That's right.
And I think that's a horrible way to live.
So the worldview of atheism and theism are very different from one another. It really has great ramifications. And I'm really concerned about Christians who ought to be having a theistic worldview
right.
rather than atheistic worldview.
But we get contaminated by our culture, don't we?
Yeah, we sure do.
A lot of Christians aren't forming their worldview from knowing God. They're forming it from living in a culture that doesn't believe in God.
Yeah. Let me give you a little illustration
okay.
of some of the things you might notice about worldview.
Share with us, please.
I'm going to show a couple of photos here. Here's one. This is a famous Horsehead Nebula. It's called that because as you can see a little, well, I'll circle it for you so you can see it better. Let's try blue. That doesn't work so good. Let's try green. That's better.
Yeah.
Kind of a horsehead shape.
Right.
Kind of a silhouette. And what we have here is a large region of hydrogen gas up here. And down here is a big cloud of dust, little tiny microscopic particles. And you have bright stars in amongst this gas that's causing it to glow. That bright red color tells me that. That's from the emission of hydrogen gas. The ultraviolet radiation from the stars ionizes the gas and the electrons recombine to give off that light. And then down here you have this big bank of dust that blocks off the light of more distant stars. You can see more stars here than you can down here. That's because we're blocking the view, blocking our view. Yeah. And a little appendage comes up right there to mark the Horsehead Nebula. It doesn't really look like a horsehead in 3 dimensions, probably, but in 2 dimensions it's nice. These two stars right here are surrounded by a big bluish cloud. That's because they're real close to the dust, but in front of it. And the light's reflecting off. We call that a reflection nebula. And we've all learned this really in 20th century astronomy and now 21st century astronomy. Here's another photograph. This is of a comet. Down here there's a little nucleus a few miles across, made out of ice and dust for the most part. And the sun's radiation and heat evaporates a lot of the dust and gas, and then it blows the dust and gas away to form the two tails, the gas tail and the dust tail. And the sun is down off the lower left. And we have a good understanding of what's going on in this kind of system all the way around. So comets are beautiful. but we have a good understanding of what's going on physically amongst all those things. Then here we have the famous Ring Nebula. It's a very famous picture. Many people have seen it before. We have the ring showing up there nicely, and it's really more like a soap bubble, a big shell of gas. And only on the edges of the shell does the gas pile up enough that you can see it. And the gas is heated by frictional impact of gases running into one another. Oh. We believe that this thing was blown off by that star right at the very center. In the past, it blew off the outer layers. Not in a big explosion, more like winds that blew off. And this is the type of thing we call a planetary nebula. Bad name, it has nothing to do with planets, but we call them that. And they're all very beautiful objects. They're just lovely things. And we have a very good understanding of what's going on in each one of these things. Now, I showed you these 3 photographs very quickly to illustrate something. I asked the question, what did you see? Well, we saw a number of interesting physical processes. Subliming gas, dust being blown away, hydrogen emission, ionization of gas, all sorts of neat things. And all that's true. It's a lot we can learn about the world around us. I think that's part of the commission that we were given in the garden to explore the world, to have dominion over it. I think science is part of that dominion. But there's more to it than that. We also can see the Creator's handiwork.
Yeah.
And I think of all those astronomers out there who are seeing these neat physical processes but fail to see God's handiwork. And they see some of the physical processes, but they fail to get the most important point.
Yes.
It's showing God's handiwork and showing His existence.
Yeah.
And that's really sad, because you're missing the whole point then, aren't you?
That's why God made it.
The whole purpose is lost on people like that, and that's really sad. To the Christian, it's particularly sad when they fail to see those sorts of things. Now, I am concerned because design really is not a conclusive argument, because I've found it's not really a head problem, it's a heart problem. If a person doesn't believe in design, then they're not going to see it. They're going to refuse to see that design, even though it's as plain as can be before them. And if you already see it, then just going to confirm what you already believe or already know. So you're going to likely ignore the evidence. So let me share with you a couple of aspects where I think design becomes very important. This is a photograph of a total solar eclipse. It doesn't happen very often. The moon passes in front of the sun and blocks out what we call the photosphere of the sun, the bright part of the sun. And for just a brief few moments, maximum of 7 minutes, usually it's shorter than that, you can look at the sun very safely, very beautifully. I read once many years ago that for any given location on the Earth, a total solar eclipse happens once every 4 centuries.
Wow.
So if you're going to actually see one, you're going to have to travel there some distance to see the thing. And this is a professionally done photograph. We have here the solar corona, this big thing outside the sun there, that glowing sort of thing. That's the corona, the crown around the sun. And it takes a camera, normal film camera, a couple of seconds exposure to show that. And down near the edge of the sun, there are these little things called prominences, which we can't see here because they're overexposed. If you take a very short exposure, you see the prominences looking like this, these big blood red loops showing up on the edge of the sun there. And they look that color to the naked eye. During a total solar eclipse, you can see these things. Very pretty. The neat thing is no camera does justice to this. Again, a short exposure or long exposure shows you certain aspects, but the eye sees it all.
When you're seeing that, and you were telling me that it's not safe to look at it right before and right after the eclipse, but when the eclipse is on,
if it's
okay
a total
to look
eclipse, only for those few seconds you can safely look at it.
Okay.
Now, you know, back in 1979, in February of '79, my wife and I went to see a total solar eclipse. We lived in South Carolina then. We drove 3,500 miles in round trip in 5 days for 2 minutes and I think 47 seconds.
Where did you go?
Manitoba.
Okay.
Actually about 100 miles north of Winnipeg.
Wow.
Or I call it Winterpeg.
Yeah.
Because it's really cold in February.
Reasons. That's right.
The snow is about that deep, and from South Carolina, that's a lot of snow. And I took this photograph when I was there. And this is what's called the diamond ring effect. The sun's moving from the moon's moving from right to left. You can see a few of the prominences peeking out here. Right. But what really makes the photograph the diamond ring effect is right here. This little bit of the sun is the photosphere is just starting to peek out. Not safe to look at, by the way. I was snapping pictures really fast, trying to catch this. And the Lord was kind. I was able to catch it, even though it lasted a fraction of a second. And it does look like a diamond ring with the ring
really
here
does.
and the band around there. And it's really interesting. We ran a tape during all this. My wife was she's much quieter than I am, and I'm more talkative and outgoing. We played the tape back later. It was really strange. I hardly said a word, and my wife was just yakking away during the entire time. And it has a strange effect upon people. I was snapping pictures. I forgot to bolt down the tripod on the camera, and I didn't have enough sense to try to bolt it down. The camera was flopping all over the place. And after a while, after I was taking pictures for a few moments, I said, this is silly. I'm just taking pictures. I need to enjoy this. So I just knelt down in the snow and just looked around at everything, tried to drink it in. I've seen a lot of neat things in my lifetime, but the total solar eclipse is the most beautiful thing I've ever seen.
Now, that's the eyes of an astronomer, but that's true. It's
also the eyes of anybody else that's seen one.
You were really impressed, and so was everybody else.
Anybody that's seen one will tell you that. Well, what about total solar eclipses? It's interesting. The moon is 400 times smaller than the sun,
right?
But the moon is 400 times closer to us, which means the sun and the moon are about the same size in the sky, and the moon just barely covers the sun up.
That's amazing. So even though it's 400 times smaller because of the distance, they come out the same in the sky.
Same size.
Yeah.
And what that means is that the moon just barely covers it up, and that produces a couple of things. First of all, very spectacular eclipses. If the moon were any smaller or farther away, we wouldn't have any total eclipses at all.
Right.
If it were closer or larger, the eclipses wouldn't be very spectacular. And furthermore, the eclipses would happen all the time. They wouldn't be as rare as they are. Typically, there's a total solar eclipse somewhere in the world about every 18 months or so.
Oh, okay.
Not real common, but you have to go to places like Siberia
Yeah.
or Timbuktu or Antarctica or Greenland or something like this in order to see these things. And you know, I've looked at all the satellites in the solar system, and this is the only planet on which this is true, these extreme
I didn't know that.
conditions.
That's fascinating.
It's
Yeah.
also the only planet that has things that can appreciate it living on the surface.
God did that for us. That's
Yeah.
right. Yeah.
And this is a photograph of the moon taken at first quarter. And it's the best time to look at the moon because you'll notice that you can see craters very nicely along what we call the terminator of the moon. And that's because the sunlight's coming from the left. And these are right at the sunrise point on the moon.
Okay.
And so a little tiny hill casts a very long shadow. So the craters and other features really leap out at you. People think full moon's a great time to look at the moon. I don't like full moon because it's not good to look at, and it's not good to look at anything else because it's so bright it blots out the light of fainter objects. Well, the moon has some design aspects. For instance, it's fairly large when compared to the parent Earth. In fact, even though there are many satellites in the solar system, our own moon is closer in size and mass-wise to the Earth than any other planet satellite is to its parent planet. The moon only has like 1.5% the mass of the Earth, but usually the other satellites have like 1/100%.
Okay.
So it's a very large mass body compared to the planet, and it orbits the Earth in the same plane that the orbit of the Earth around the sun follows.
Yeah.
You know, our actual tilt is 23.5 degrees, and the moon could be in that equatorial plane, but it's not. It's in what we call the ecliptic plane, the plane we follow around the Earth. Now, this is interesting. I learned this just a few years ago, thought about it, understood the implications. There are many satellites in the solar system. No large satellite in the solar system has that kind of orbit. All of the others orbit in the equatorial plane.
Huh.
And that's interesting. It tells us several things. One, it tells us the origin of the moon is different from the others. But the one thing that happens, and it took me a while to really appreciate this, it stabilizes the Earth's axis of rotation, that 23.5 degree tilt. Without the moon, with that kind of orbit and that kind of mass, the Earth's tilt of axis would go from very high to very low values, and we would go from being in the tropics to being in the polar regions without ever having to move. It's a very long-term thing, but it would wreak havoc upon the climate, upon the living things upon the planet. I don't think it's any accident that we have this kind of moon and this kind of orbit on this kind of planet where only living things are known to exist for sure. And another thing that's very interesting, the whole story, we can do a whole show on this sometime if you'd like. I think our own moon made physics possible because the motion of the moon is the big question that Sir Isaac Newton was studying 400 years ago when he was trying to work out his theory of gravity. Without the moon, he couldn't have done that.
Well, that's very fascinating, and to me, you're just screaming design, that
Yes.
this could not be by chance, it was by design. But everyone doesn't see it that way. We've got to go to a break right now, but we'll be back in just a minute. I know you're as fascinated as I am by how astronomy teaches us that we have a God who is a designer. Don't you go away, we'll be right back.
Creation versus evolution. You weigh the evidence. Neptune's wonders. Fascinating activity. Neptune is an amazing planet that can't be explained by long ages of time. Astronomers were amazed to discover that Neptune is very active even though it's so far from the Sun. Winds can reach 1,300 miles per hour and the planet actually generates heat. Evolutionists keep looking for some weird scenario to explain Neptune. Unfortunately, many astronomers prefer to keep inventing fables rather than admitting to a creator. Today's guest on Origins, Dr. Danny Faulkner, is also the author of Universe by Design, an explanation of cosmology and creation. This is an excellent book for upper-level homeschool curriculum or the library of an astronomer. Orders are being taken at 1-877-CRS-BOOK. Dr. Faulkner has a degree in math, his master's in physics, and a PhD in astronomy from Indiana University. He is full professor at the University of South Carolina, Lancaster, where he teaches physics and astronomy. For more information about our guest, you can write to Dr. Danny Faulkner, 1402 University Drive, Lancaster, South Carolina, 29720. Or send him an email.
We're back with Dr. Danny Faulkner, and we've been talking about design and astronomy. Dr. Faulkner, we were talking about the uniqueness of the moon. Now bring this back to Earth. How's the uniqueness here come into play?
Because the Earth is a remarkable place. Okay, it really is remarkable when you start thinking about
my
some of the
favorite planet.
My favorite. Actually, I kind of like Mars, but you know, we talk about. First of all, how far a planet has to be from a star like the sun in order to support life. Obviously, if it's too close, it's too hot. If it's too far away, it's too cold. So there's this region we call the habitable zone around the sun. Guess where the Earth is?
Right in the sweet spot.
Right in the sweet spot of that habitable zone.
That's right.
And we got a couple of planets nearby, Mars and Venus. One's too close and one's too far from the sun. They're just outside and inside of this habitable zone. So it's a pretty narrow range. But you know, being inside that habitable zone is not enough. The moon, for instance, is the same distance from the sun that the Earth is. But it's not habitable either, and there's a problem there because it doesn't have the right size and the right composition. The size, I mean, its mass is too small, so it doesn't have enough gravity to hold an atmosphere. Without an atmosphere, you can't breathe, but beyond that, you can't have liquid water, all those kind of things. Also, the moon is void in a lot of the heavier elements, things such as iron, which is essential for life. You know, blood has iron in it.
Yes.
There's not a lot of iron on the moon, very little on the moon, and some other heavier elements that are absent. So the moon, even though it has one parameter that's good, it's missing many of the other parameters. And we look at other planets, not only in our own solar system, but now we've discovered hundreds of planets orbiting other stars, what we call extrasolar planets. And what we find very interesting is that we need the right kind of atmosphere. What we have is what we call a diatomic atmosphere. Diatomic means two atoms. The molecules in our atmosphere are made of two atoms for the most part. The dominant one is nitrogen, nitrogen 2. That's about 78% of the Earth's atmosphere, and the other next 21% is O2, oxygen 2. So 99% is just those two diatomic gases. Oh, what's the point? Well, polyatomic gases have 3 or more atoms. Water vapor is one of them. Carbon dioxide is another one. Methane, things like the ammonia.
None of those sustain life.
Well, even worse, they block in heat. They're called greenhouse gases. You've heard a lot about the greenhouse effect and all this kind of stuff. And well, if you need a little bit of greenhouse gas in the atmosphere to keep it warm, but too warm is not good either. And as it turns out, all the other atmospheres we see on other planets, they're polyatomic. They're not diatomic. And we're pretty certain that you need a diatomic atmosphere to sustain life once again. So just again here, the Earth hits the jackpot, as it were, if it's simply a random sort of process. No other planet we know of can support life. Another thing that's important is water. Not just water, but liquid water. I think water is probably the most common molecule in the universe. We see it in space between the stars.
Right.
We see it in the atmospheres of some cooler stars.
We've seen it in the comets.
We see it in comets. We see it on planets.
Yes.
We see it on satellites. But everywhere we see it, it's gas or it's solid.
Ah.
There's some hints that a couple of moons of Jupiter might have some liquid water underneath, but that's not for certain yet. As far as we know, factual information right now, the Earth is the only place in the universe that has liquid water.
Amazing.
You need the right pressure, you need the right temperature regime, and liquid water is the universal solvent that is vital for life. We can't imagine a life not existing in those sort of circumstances. Now, we don't have a lot of time to talk about all the features that the Earth has. These are some of the more obvious ones. But the Earth is this place that's ideally suited for our own existence. Life would be impossible if you take any of these things away. And there are other planets out there. Venus we've already mentioned. It's closer to the sun. It's a very hot place. We heard about the greenhouse effect. Well, they've got a polyatomic atmosphere that won't quit. You know, the surface temperature on Venus is like 900 degrees.
Wow.
But there's no water, so it's a dry heat, you see. And it would melt lead and other common metals like that. Life can't exist there. And then you go out to Mars, the next planet out, and it's way too cold, and the air pressure is very low. If you release liquid water on the surface of Mars, part of it would freeze, part of it would vaporize and boil away.
Now, this is one where always I'm hearing how desperate scientists are to find water on Mars because it will be a hint that, that life was on Mars. Is that?
Well, there's evidence that water once was abundant on Mars. We see flow patterns. Right. We see appear to be shorelines on hillsides. But the thing is, liquid water doesn't exist there today. It's a big mystery about where the water came from, what happened to it. We've got some different theories about that. Water was once abundant when it was a wetter, warmer place, but the water's now gone. So life can't exist there today. Questionable if it ever could have existed in the past. I like to call the Earth kind of the Goldilocks planet.
Yeah.
Because it's not too hot and not too cold. It's just right here in the middle of all this. And the moon, I've already mentioned, it has no atmosphere. It's the right distance, but it's missing a few other things. So I think maybe the reason why the Lord made the moon like he did and made Mars and Venus like he did was to show us just how special and unique the Earth is and how ideally suited it is, and it's no accident. Now, secular astronomers, secular scientists have understood this. A term was coined in the early 70s called the anthropic principle, and that idea is that the universe appears to be ideally suited for our existence. You look out there and you see certain aspects, certain characteristics of the universe that seem to make that happen. Anthropic meaning, of course, people. And in fact, there was a book written a few years ago called The Anthropic Principle. They gave a big, long history of it, discussed every bit of it. And you know what their conclusion was? Their conclusion was that the universe only appears to be designed. It's all an illusion or an appearance. They admitted that it appears to be designed, but it's just because it looks that way. And that's what we're dealing with, Don. You got people who have hardness of hearts, that they're bombarded with all this evidence of design in the world around them, and then they deny that design and say, well, it just looks that way.
Dr. Faulkner, you're making me want to pull my hair out. I mean, you wonder how much evidence would be enough evidence. Yeah. And your answer is basically, if your heart isn't right, there'll never be enough evidence. And so the conclusion that believers like you and I reach is that we ought to thank God for Earth.
Yes.
And how perfectly He made us for it and it for us.
Yes.
And it's a gift from God, isn't it?
It is.
Both in its beauty, but also in its ability to sustain our lives.
Wonderful gift to us.
What a blessing you've been to us today.
Thank you.
We're thankful for your life and the way you're using it to declare the glory of God and to point out the majesty of His creation. Thank you, sir. And you know, I hope each of you have a heart that's open to receive and to see the evidence of a God who has made a great earth. He made you to live on this planet, and He made this planet for you to live on, and they are perfectly suited to each other. I hope that you'll look at the heavens declaring the glory of God on this earth, and you'll allow it to open your heart to know Jesus Christ as your Lord and Savior, and allow Him to prepare you not just for life on this earth, but for eternal life. That's going to be my prayer for you today, and I hope that this won't be the last time we're together. I hope that you'll remember this above everything else we've heard today. It's God's view that He created you, and that should be your worldview too. I hope to see you again soon here on Origins. Until then, God bless you, my friend.
thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 902 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 902, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.